Good evening. My name is Aromz Daniel, a student of Obafemi University, Mechanical Engineering, matric number ME 2023/087. So I'm here to present my code for the lab 5 and lab 6 experiments. So for lab 5, I was given question number 16. A minute please. So I was given question number 16, which is classify an applied load as compression, tension, or no load. Ask for a load force in Newton. Print compression load if load force less than 0, tension load if load force greater than 0, or no load if load force equals to 0. So this is my this is the code I have written to carry out the task given to me by Dr. Gambo for my CSC 202 practical. So the purpose of this code is to take a load value from the user, and based on whether it is negative, positive, or 0, determine the type of load. So for my line 1, we use input function to ask the user to enter the load force in Newton. We convert it to a float to handle decimal values. So for my next line, then we use simple conditional statement as follows. If the force is less than 0, we print compression load. If the force is greater than 0, we print tension load. If the force is exactly 0, we print no load. Now let's take for example. If the user enters -50, the output will be a compression load. If they enter 100, it will display tension load. And if they enter 0, the program will print no load. This is a simple but practical example of how Python can be used to analyze forces in mechanical or civil engineering application. So that's all for my lab 5 question 16 practical. So now I'm going to move to my lab 6 question 116. So the question states that 1 minute. Question 116. Um, Model a generic sensor that records and updates reading. Create a class sensor with attribute sensor ID in bracket strange. Units in bracket strange, e.g. Celsius, PSI, etc. close bracket, and current reading in bracket initial 0.0. Add a method update reading into bracket new value close bracket that changes the current reading. So this is my code for that. 1 minute. So this is my code for that. So the goal is to create a class that holds a sensor's ID, its units of measurement such as Celsius or PSI, and its current reading which start at 0. The class also allows us to update and update the reading when new data is received. So for my line 1, we defined a class named sensor constructor in bracket. The constructor takes two parameters, sensor ID and unit. These are stored in the object. We also initialize the current reading by default. For example, we can create a sensor like this. S equals to sensor S1 into bracket PSI. Then we can update its reading. S update underscore reading 45.6. And finally, we can access the current reading using S current underscore reading This simple class is useful in larger systems like IoT networks, industrial monitoring, or environmental sensing, where we need to track and update sensor data efficiently. Thank you and God bless you. Once again, my name is Aronkola Oluwatofeyinti Daniel, student of Mechanical Engineering, matric number ME 2023 087.